Hello everybody. Welcome and thank you for joining us for the second installment of Ignite Talks here at MSU. I'm Dr. Abby Stevens, the Public Programming Manager at the MSU Museum, and I'm also the Ignite MSU chapter leader. So it has been my pleasure over the last 2 months or so to work with 9 research rock stars who are students here at MSU at various levels, graduate and undergraduate, who are doing research on really cool topics. We have people from, I believe, 6 different colleges, and everyone is from a different department. So it's been fascinating to learn all about the work that they are doing here at MSU, and to also help them be able to tell their story to all of you tonight. So I'm going to give a brief overview of what Ignite Talks are, in case someone dragged you here and you're like, that sounds weird. Don't worry, I got you. So for Ignite Talks, they are 5 minutes flat for one big idea. And to get those 5 minutes, you have 20 slides that auto-advance every 15 seconds. The auto-advance is, I'm sure the speakers will tell you, the hardest part of all of this. You have to have things well choreographed. Ignite started in San Francisco in 2006, so it has been around for quite a while at this point. Since then, it has been in over 350 cities across 6 continents. And we are the only one currently in Michigan, which is lots of fun. So to get the students who we have for Ignite, we have an open call for students doing research projects in any field here at MSU. Previous public speaking or stage experience is not required. We have a research communication workshop, and we had a dress rehearsal with one of the acting professors, Rob Resnowski, to help students hone their craft on the stage. We then selected 9 research rock stars and the research communication workshop, and we are looking for more students in the fall. This is our 2nd iteration of Ignite, and we are really excited to do this again in the fall. So please keep an eye out in museum communications for the open call for that. So this evening, we are going to start off with 5 talks after I stop talking now. Then we will have a brief intermission where you can use the bathroom, get a drink of water or something, chat with your neighbor, and then we will have 4 talks after the intermission. Interestingly, there is no Q&A involved here. You are welcome to ambush a speaker at the very end of the whole thing, politely, gently, but there's no Q&A following the talks. So it's a very dynamic, fast-paced evening. And with that, I'm going to get queued up for the first speaker. Okay, so our first speaker this evening is Alyssa Saunders. The spoilers.
All right, hi everyone. Like Abby said, I am Alyssa Saunders. I'm a 3rd-year PhD candidate here at MSU in the Integrative Biology Department, and today I'm going to be telling you about the shockingly tailless sperm of African electric fish. But first, let us talk about Abby, save me. What happened? I don't know. Sex. It sells, it smells, and it's the way by which we and the majority of other animals ensure that our species keeps on keeping on. Sex can look really different for different species, but when you get down to it, you just need 2 things, a sperm and an egg. And when these 2 cells come together, you're going to get a zygote, which eventually will grow into you, or a fish, or an insect, or whatever species that we're dealing with here. The coming together of these 2 cells is known as fertilization. And you likely have some idea about what this looks like in your head, probably something like this, where you have a bunch of little sperm all swimming with their tails, racing to be the one to fertilize the egg. This kind of cartoon idea of what a sperm looks like is pretty close to what we see in real life. So shown here is a human sperm, and we can see that it has 3 main parts, a head, a midpiece, and then that tail for swimming. But honestly, human sperm is pretty boring, considering that sperm is the most diverse cell type that we know of, demonstrated here by this beautiful collage of sperm from animals across the entire tree of life. But as with everything in life, there are exceptions. Oh, they all have heads, midpieces, and tails. I forgot to mention that. Almost all of them, you can see it really well when they're lined up like this, all in the same orientation. But now, as with everything in life, there are exceptions, and this is where tailless sperm comes in. Tailless sperm has evolved just 36 times. 35 of those evolutions have happened in invertebrate lineages, and only once has it evolved within a vertebrate lineage. And that lineage is the myrmirid electric fish. This is actually a pretty large group of about 230 species found in lakes and rivers across Africa, and they're able to use electricity to communicate with one another and to also navigate through their environments. The sperm of these animals was first imaged in about the early 1970s, and you can see them here. There are these oval-shaped cells with no tail to be seen on them, and this means that they also can't swim or really move on their own at all. So right about now, you're probably thinking something like, if sperm swim to reach the egg in order to fertilize it, then how does myrmirid sperm even work? It can't swim, it can't move. Well, the answer to this question is, I don't know, but it's part of what I'm trying to find out, starting with getting some updated images with updated imaging technology. Because as you can imagine, microscopes have progressed a lot in the last 50-something years. So in my lab, we've gathered myrmirid sperm samples, threw it under the scope, and here's what they look like. As we expected, they're these little oval-shaped cells, and our images here just doubly confirm, yep, there's definitely no tail on these things. Now, there's actually a pretty big piece of this puzzle that we haven't chatted about here yet today, and in fact, no one has really studied before at all, and that's what these tailless sperm are actually fertilizing, myrmirid eggs. So we've also collected some eggs in my lab and imaged them, and here you can see the surface of an egg, and pointed out is the hole where sperm is able to enter, and notably, there's a little bit of a difference in texture around that hole versus the rest of the egg. So then, if you were to go ahead and zoom in to an area near that sperm entry point, what you're going to see are a bunch of even smaller holes, just used for things to move in and out of the egg, but also all these little tufts of hair scattered across the surface. Then, if you were to go ahead and zoom into a point that's further away from that sperm entry point, you can again see a couple of those holes used to move things, but now you can also see longer versions of those little hairs. So the question is, what are these things doing? Well, if we compare to other fishes, some of them have long egg hairs used to attach to surfaces. Myrmirid hairs are probably too short to do this, but some fish have these kind of features like spirals that guide sperm to that entry point, so maybe they do that. So why do you care? Well, on the practical side, issues with sperm tails are a common cause of infertility, so by studying tailless sperm, we may be able to find mechanisms that lead to sperm tail loss, and that could be something to look for in humans as well. But on the more fun side, biology is weird. And I think that there's inherent value in studying our biodiverse planet and understanding the beings that we share it with, like little fish that make electricity and sperm without tails. Thanks.
Awesome. Thank you very much, Alyssa. Up next, we have got Hakan, Burak, Karli of the College of Engineering. There you go. 3, 2, 1.
Hello, everyone. I'm Hakan Burak Karli from Electrical and Computer Engineering, and I will be talking about my project. So basically, we are here to revolutionize neonatal care, ensuring every individual from their first breath receives equitable health care. The challenge we face isn't just confined to newborns. It affects people across all ages. Since 1976, the percentage of deaths due to respiratory health has increased only 3%. Doesn't seem much, right? But this seemingly small increase translates to 150,000 lives with staggering 273% rise in mortality, a number that cannot and should not be overlooked. A significant contributor to these deaths is tied to a device that we have trusted for decades, the pulse oximeter. Designed to measure oxygen-bound hemoglobin, this tool unfortunately harbors racial bias. A pulse oximeter were designed considering how skin color can affect light absorption. Light goes through the finger during the process and goes out on the other way. So for darker skins, this means getting inaccurate readings, unfortunately. And this isn't just a technical problem, it's a matter of life and death. So my connection to this problem began while choosing becoming a doctor or an engineer. So during one of the visits to my father's clinic, I met Nazlı, a young girl with joy for life who later became a victim of the issue that we are discussing today. So after a routine operation, Nazlı's condition got worsened. Unfortunately, pulse oximeter biased against her darker skin provided wrong readings, and unfortunately, Nazlı didn't make it. So driven by the tragedy of Nazlı's loss, my career path was clear: to create a world where every newborn has access to fair and accurate healthcare monitoring by joining my team right now. So this was my turning point, actually. Our mission is simple, yet clear: to create a world where every newborn has access to fair and accurate health monitoring. By introducing a new device, we are setting new standards for healthcare technology to ensure every child can access fair healthcare. So in hospitals, we rely on 3 methods to measure oxygen: ABG, which can be painful due to puncture, pulse oximetry, known for inaccuracies, and other commercial monitors, which are not continuous or not variable. If we look at the timeline of oxygen monitoring, we see a lot, right? But now let's not talk about the past, all right, for a second. Let's talk about future. I want you to meet with Mo, our device. So our device basically has a groundbreaking approach with using optical science, optical values, optical technology. So with this device, we can detect, basically this project is more just creating something new, something better. So it's about making life equal for everyone in this world. So you may wonder how this device works, right? Mo uses light to emit and detect from our sensor. And with this data, basically we get the signal back. So using this signal, we basically work better, faster, and more accurate. So with using, as we said, we capture the data through incoming light. And with using this data, we basically develop racial bias mitigation algorithm in order to reduce bias in pulse oximeter readings. So if we look at the project plan, we basically passed the first prototype and we are doing some human trials right now. With using that data, we are going to develop a second prototype, then move forward to human pilot studies. So at MSU, we are trying to build the computational model in order to see how oxygen diffuses through the skin. And with the help of that data, and with some machine learning and signal processing techniques, we are going to reduce the bias in SpO2, pulse oximeter readings. So with Mo, we aim for greater things other than something just in the lab. We aim for equity in healthcare, lower costs, reduce hospital times, and much, much more with this device. As we stated, we started human trials right now, and from the graph, you can see that we can detect occlusion and hypoxia just fine, which basically means we have a potential here. So I want to thank my team for their unrelenting support, WPI for the first prototype, UMass for the first trials, and NSF and NIH for funding. We are pushing neonatal care forward together. Thank you.
Thank you very much, Hakan. Okay. Okay, up next from linguistics, we have Yaxuan Wang.
Hi everyone, my name is Yaxuan from Linguistics Department, and today I will talk about the hidden rules behind emoji. So, consider this question: are emojis, these icons, used randomly, or is there an unconscious rule behind them? So look at this daily life conversation. John lost the game. He's so upset right now. Sad face. I'm happy that he's being upset. Happy face. The game reminds him not to be arrogant. And clearly, we know that the boy is happy, but the girl is happy. The girl is sad, but the boy is happy. But now we turn this face to one to the positive and the other to the negative. It's hard to interpret the boy's message now because he's stating, I'm happy, and as well as using a sad face. So this may tell us that emojis always refer to the speaker's attitude, but not the sentence subjects. Here, refer to the girls and the boys' attitude, but not John's. To make an analogy, if I'm say, I made a tiny cookie while stretching my arms, it's hard to interpret my message because my gesture and my utterance does not align with each other, right? And it is the same thing for the usage of emojis. If you want to use the happy face, you must utter that I'm happy. So with this property, we may take the advantage of emojis to help people suffering from alexithymia. So the alexithymia people are those who have difficulties in interpreting other people's emotions as well as expressing their own feelings. There's a recent study which states that emoji use is quantitatively but not qualitatively altered in alexithymia. So when people cannot interpret the written text, they can always resort to emojis to help them interpreting other people's feelings. But there are some difficulties in our research. That is, how's your exam? It's not difficult at all. Smiley face. Clearly, there's some ironic usage of emojis, and we need to figure that out in our ongoing research. Okay, let's look at another sentence. The girl is photographing the dog. As native English speakers, how do you use emojis to represent this sentence? You will use girl, camera, and dog in this order, right? But as a native Chinese Mandarin speaker, the word order in this sentence is reversed: girl, dog, and photographing in this order. We may predict that I will use girl, dog, and camera in this order. But based on the research I conducted, it seems that both Mandarin Chinese speakers and English speakers will use in this order. So it seems that emojis, the plain emoji sequence will always encode the spatial and temporal information we observed in the real world, but not the linguistic information encoded in our grammar. And we use this property to help people suffering from aphasia. So those are people who lost their words, and this can lead to anxiety, depression, and social isolation. Well, this is not a tiny problem. So based on the National Institute on Deafness and Other Communication Disorders, 1 in 272 Americans have aphasia, and 180,000 new cases are identified each year. But most aphasic patients understand emoji. We can just translate those written tests into a sequence of emojis to help people understand and express their own feelings. But there's some caveat. That is, there are some emoji preferences, variations among different groups of people. So a survey suggests that younger people tend to use emojis more innovatively. They tend to use the facial expressions. By contrast, more senior people tend to use just the simple objects to refer back to the written text they mentioned in their test. And in terms of gender, it seems that females tend to use the positive faces to express the positive feelings. And they tend to use emojis more frequently compared to males. Okay, when it comes to males, they do not use emojis in positive environments, basically, but they tend to use emojis to express negative feelings. Okay, in conclusion, it seems that the ungrammatical emojis do facilitate the grammar, and we can use different properties of emojis to help people suffering from different language disorders, and this can help us uncover different aspects of our social life. Thank you.
Thank you, Yaxuan. Up next, we've got Logan Soule from the Department of Biomedical Engineering.
What if I told you that your blood donation can sometimes cause more harm than good for transfusion patients? Hi everyone, I'm Logan Soule, and I'm here today to talk about some of the incredible improvements we're making in the way we store blood, specifically its sugar content. Now, I do not want to discourage you from donating blood. Blood transfusions are most certainly life-saving procedures for a variety of patients, requiring more than 29,000 red blood cell units each and every day in the United States alone. But that does not mean they are without risk. You see, blood transfusions can sometimes cause unexpected complications for patients, including inflammation, tissue swelling, infection, and even organ dysfunction. So why does such a vital cell therapy cause so much concern for the patient? Well, the answer may be due to what's called the storage lesion. You see, your red blood cells simply are not meant to be removed and stored outside of your body. And during storage, they begin to age and deteriorate, losing properties vital to their functionality. And this can cause them to function poorly when transfused, including disrupting their ability to squeeze through blood vessels and deliver oxygen, resulting in up to 25% of those transfused cells being cleared within the first 24 hours. So why do these red blood cells deteriorate during storage? Well, they are stored in extremely sugary storage solutions that allow them to survive and metabolize that sugar for up to 42 days, generating energy, but also waste and harmful reactive oxygen. And during storage, there is simply nowhere for these waste products to go. Normally, your body would eliminate them from your bloodstream, but their accumulation and storage begins to damage these red blood cells and prevent their proper functionality. So, is sugar the problem here? You see, red blood cells are stored at sugar levels that are 8 times higher than the bloodstream of a healthy individual. And interestingly, both diabetic and stored red blood cells have similar problems, both being rigid with poor ability to flow. So what if instead we stored red blood cells at normal sugar levels? After all, this is what they experience in the circulation to begin with. So storing red blood cells at normal sugar conditions may help prevent some of these storage-induced damages. And it turns out that low sugar blood storage significantly improves their functionality. For example, they are much more deformable, allowing them to squish and squeeze through small blood vessels much better, and potentially leading to better oxygen delivery. Also, they're much more resistant to bursting under salt-induced stress. You see, red blood cells stored under normal sugar conditions don't swell up as much when placed in a low salt environment, and this might be a significant advantage when transfused into the circulation. And lastly, there's also significant reductions in oxidative stress. You see, as reactive oxygen builds up in storage, it can be very harmful to these cells and is thought to be a main contributor of many of these other storage-induced damages. So low sugar blood storage may avoid some of these problems. And you might think that less sugar would then mean less energy for these cells, but what's great is that it doesn't. Based on key indicators of energy production, we see there's no difference in the energy levels between low sugar storage and high sugar storage. So what's really going on here? We're not completely sure, but we do know that excess sugar might be made available for other pathways to break down this sugar into harmful products that might cause damage to these cells and prevent their proper function. So there's only one problem with low sugar blood storage, and it's that it requires these cells to be fed with concentrated sugar every 2 to 3 days to help maintain those energy levels. But this introduces many problems when translating this technique into blood banks. You see, blood banks simply would not be able to manually feed the millions of red blood cell units collected each year with sugar every 3 days. And also, this would increase the risk of contamination and therefore the risk to patient safety. However, I've been able to solve this problem by implementing an electronic valve that can be programmed to open and close, delivering small volumes of concentrated sugar to these cells every 3 days. And by using this technology, I was able to maintain sugar levels of these cells between a normal range for up to 39 days, while also maintaining sterility for the complete storage duration, thus overcoming significant limitations of implementing this technology into blood banks. So where do we go from here? Well, low sugar blood storage clearly results in significant benefits to these red blood cells and has promising potential for patient benefit as well. And it's now possible to implement this technology at a larger scale and measure transfusion responses from animals. Clearly, there's plenty of room for improvement in the way we store blood, and low sugar blood storage offers a promising alternative to current methods and may result in improved patient outcomes. So who wants to join me in putting stored blood on a low-carb diet? Thank you.
Okay, now we are going to hear from Steensma of Plant Biology and Molecular Plant Sciences.
Hello, so my name is Anne. I'm a third-year PhD candidate in the Plant Biology and Molecular Plant Sciences programs, and tonight I'm going to talk about my research studying microbes that thrive in acid baths. So if I asked you to think of an organism that makes its own food using photosynthesis, you might think of a tree or a flower, probably something that grows from the ground, maybe something that you might find around here at MSU. But in fact, organisms are doing photosynthesis in all kinds of environments around the globe. For example, half of the carbon dioxide that is used in photosynthesis in the whole world is used by organisms that live in water. This means that in wet places around the world, this magic of photosynthesis is happening, and organisms are using light and water and carbon dioxide to make the sugars that they need for food. And green organisms are thriving even in places that don't seem friendly to life. Even in volcanic hot springs, you can find these vibrant green mats, and these are made up of creatures that are only 1 cell large. Some of them are so small that you need to stack about 50 of them to get up to the thickness of a piece of paper. These tiny creatures are small but mighty extremophile algae, which are capable of thriving in an environment that's basically a hot bath of sulfuric acid. It's hot and acidic enough to burn you, and it contains a sprinkling of toxins like heavy metals. So to survive in this harsh environment, these algae build their cells out of building blocks like proteins that are specially formed to function under high heat and to protect cells from heat. They also have cell surfaces that can resist acid or pump acid out. And these algae are really good at detoxifying toxins like heavy metals that build up in their environment, so much so that people are even trying to figure out how we might be able to use extremophile algae to clean up polluted wastewater. And in the middle of all this, algae have to worry about making a living by photosynthesis. And this is hard because under extreme conditions like heat and acid, most organisms have trouble getting photosynthesis working well and getting and using the CO2 that they need to survive. So to learn more about how organisms can thrive under inhospitable conditions, we brought one species of extremophile algae into our lab to learn more about how they can survive whatever volcanoes are throwing at them. And one thing that we found is that extremophile algae are really efficient at photosynthesis. This means that they can be quite productive in photosynthesis even when there's not a lot of carbon dioxide available to them in their environment. And one secret of how they do this is they have photosynthetic machinery that is great at selecting CO2 from the air and grabbing it for use in photosynthesis. But we realized there had to be more going on to explain everything that we were seeing. And we found that these algae also have a way to effectively supercharge photosynthesis by gathering up carbon dioxide in the cell. And this creates a kind of CO2 vacuum that ensures there's always plenty of CO2 for the cell to grab for food. And actually, lots of plants and algae have ways to gather up carbon dioxide in the cell. But we were interested to see this in a unique organism which doesn't have all the cell anatomy and enzymes that are thought to come along with boosting photosynthesis in algae. This tells us that photosynthesis is more diverse than we thought, and we still have a lot to discover about the ways that algae and other organisms build their defenses against all the different environments that they live in. So we're now studying how algae build systems to boost photosynthesis. For example, we wonder if they're creating compartments in the cell, maybe tuning pH in the cell so that photosynthesis can thrive, or producing certain proteins in response to what they sense in the environment. And this is interesting because some researchers think that extremophile algae may give us clues about what some of the earliest forms of life on Earth may have looked like. But these algae are also creatures of the modern age, and they have potential to contribute to biotechnology. For example, if we could learn more about the genes that help algae survive in extreme environments, we may be able to put some of those genes into vulnerable crops that are suffering in hot environments and other stressful conditions. In addition to resilient genes, algae also produce oils and pigments, and also ponds of extremophile algae rarely get contaminated by unwanted organisms because not many things want to live in an acid bath. There are only a few special creatures that are capable of thriving in hot sulfuric acid, and they have a lot to teach us about the diversity and the resilience of life. Thanks for coming to my talk, and I'd like to thank everyone who's supported me in my research so far. Thank you.
Thank you so much, Anne. We are now going to have about a 15-minute intermission or so, and we will see you back here. What time is it? We will see you back here at 7:55 sharp. Okay, so our first speaker now after the intermission is Amber Mostiller.
Hi, I'm Amber Mostiller from the Online Food Safety Program, and I'm here tonight to talk about my research in optimal parameters for chilling meat in food processing. So I don't want you to get sick, or worse, die from the food that you eat. So I've studied conditions to chill large roast beef products to limit the bacteria growth. And this will help you, as long as you're not vegan. So picture this. You are studying for a big exam, and you stop by the cafe to get a hot roast beef sandwich. It's really convenient to stop by and get food that's already prepared for you, especially when you have a lot going on. But a few days later, right before that exam, you don't feel so hot. You're in the bathroom with vomiting and diarrhea, or maybe you have symptoms of shortness of breath and muscle paralysis. These are all examples of different foodborne illnesses. Maybe you've heard of botulism poisoning. The botulinum toxin can grow when meat is improperly chilled after it's fully cooked. So we want to keep hot foods hot and cold foods cold. But don't worry, commercially prepared products have to meet requirements that are set by governmental agencies to make sure that they're not growing bacteria. So in 2021, the United States Department of Agriculture updated their guidelines for cooking and chilling. And this made companies relook at their protocols to make sure that they were meeting those requirements. And while those requirements covered beef, poultry, and pork items, I studied one particular beef product that the guidelines really didn't work out well for. So let's learn a bit more about that. But first, for you meat eaters, what do you think is more appealing? The one on the left that is a whole muscle product, or a section-informed product? I think most of you would agree that the whole muscle product is more premium. But a premium product can come with a lot of cost. So how can we make this a little bit more affordable? For some added value, products can be injected with flavorings. But that injection process might take bacteria that's on the outside of the product inside. So now you have this nice, beautiful piece of meat that has a higher probability that bacteria could grow. And a big piece of meat is going to take a really long time for that heat to transfer during cooking and chilling. And what do we need to do to stunt that bacteria growth? So I studied cooking conditions, or cooking methods, both open oven, open to the air, or sous vide, which is cooking in a vacuum sealed bag in water. I also looked at different ingredients to stunt bacteria growth. I looked at antimicrobial ingredients that might reduce the pathogen growth that might otherwise be there without those ingredients. But while salt can stunt bacteria growth, you don't want to feel like you're eating something and pouring salt right down your throat. This is a trend going around on TikTok. I don't suggest that you do that. So how can we balance safety, flavor, and cost? It's important to know that having safe food does not give a company a competitive advantage. All consumers expect that the food that they're eating is safe. So think of developing a product as being both a chemist and a chef. Choosing the ingredients that will both enhance food safety while exceeding the customer expectation is the true art of food processing. So all products, they have to go through rigorous development and validation process before they come to life and are available to consumers. They don't just come out randomly, they might come out in your kitchen. So considering the different ingredients and cooking methods, commercial food processors aim to make safe foods that are both delicious and affordable. So no matter what setting you're eating in, a food cafeteria, a nursing home, a ready-to-eat sub sandwich, there are professionals out there, like myself, that are making sure that the food that you eat is safe. Thank you.
Okay, the next speaker is Kaustubh from the Construction Management Program.
All right, the concrete floor below your feet and the drywall surrounding us, these all are made up of the hazardous materials. I am here to present a substitute mass timber. I am Kaustubh, I am from Construction Management Program. This research will ignite a change that will contribute to our sustainable development goals. I will be talking about the challenges, the breakthrough, and the transformation throughout. Let's talk about the first challenge. This is a beautiful Earth. Wait, it's not beautiful anymore. Because of increasing air pollution, melting glaciers, starving animals, ravaging wildfire, floods, and the plastic overload. For half of the past century, we have lost 2 million lives, 4.3 trillion in our economy, and we see 9 out of every 10 deaths are because of climate change. Do you know? We emit 36 gigaton of carbon dioxide every year. 15% of it is because of building material like concrete and steel. Replacing only 10% of it is equal to saving at least 4 billion trees. So, and the third challenge is housing crisis. US is short of 7.3 million affordable homes. So in all, we have 3 main challenges: the climate change, the CO2 emission, and housing crisis. Let's talk about the breakthrough. We all know this. The growing forests absorb carbon dioxide, and during the wildfires and decomposition, it goes again back into the atmosphere. Instead of letting it burn, we can use it to make wood products. Mass timber proposes the same. Mass timber proposes to harvest the wood from growing forest, use it to make timber products like beams and columns, and to develop a building that will be like a live tree, storing the carbon throughout its life. Now, what is mass timber? Mass timber is actually an engineered wood glued together to make building components like beams and columns, as you can see in the picture, and this will help to build a robust building just like our beloved STEM building. So, in all, mass timber have 3 main advantages. One, it is a renewable and climate-friendly building material. Second, it has a low embodied carbon than concrete and steel. And third one, it is acting as a vault to store carbon throughout its life. Now, first question, are we really cutting trees to save trees? So just for an example, at STEM building, we are storing 4 million pounds of CO2 in their wood. And you'll be surprised to know it only takes 3.5 minutes for US forest to grow this much of wood. When it comes to timber, there comes a question about fire. So from an experiment conducted at Canadian Wood Council, the building codes require us to have 2 hours of fire rating. Mass timber achieved 3 hours of fire rating. It is 9 times safer than our normal homes. Mass timber is strong. You will be surprised to know it is actually 5 times lighter than concrete. If we compare pound to pound, it is actually stronger than steel, and because of good strength to weight ratio, it is highly resistant to seismic activities. So all advantages. Now on one hand, we have housing as a crisis. On the other hand, we also have this efficient mass timber technology. What I'm trying to do here is to bridge this with modular construction to make it affordable. Now what is this modular construction? Very simple process. It is building modules in factory, installing them on site, and boom, your building is ready to live in. I would like to inform you all, the modular construction industry is not small. It constitutes of 11 billion of the market in US construction industry, and you will be surprised to know it is growing at 8% cumulative aggregate growth rate, which is actually 4 times higher than the normal construction industry. So this is the future. Moving ahead, when we combine modular and mass timber, we will be enhancing the community living by making it healthy, productive, and most important, biophilic at its core. With this research, I am attempting to transform the perception of building and building materials like this from carbon dioxide emitters to actual carbon collectors. With all this being said, I feel this is the time for all of us to call climate change, carbon dioxide emission, and housing crisis to stop, and modular mass timber has a way to go. With this, I would like to acknowledge Dr. George Burgon and Mass Timber at MSU for their continued support. And at the end, I would like to call for an action to join a movement towards sustainable, affordable housing to save the only earth we have. Thank you.
Okay, 7 down, 2 more to go. Our next speaker is Amber Proudfoot from the Fisheries and Wildlife Program.
Hello. Today I'll be talking about poison frogs and what the bugs that they eat say about their color. And I'll specifically be talking about a poison frog called the strawberry poison frog. Now these are some small, known for being bright red guys, you can see up there. Pretty aptly named, right? Kind of looks like a strawberry. However, unlike a strawberry, this frog is not tasty. If you were to eat it, you'd probably get a pretty bad stomach ache, and that is true for wild predators too. So these bright colors are quite unappetizing. When the bird eats this frog and gets that bad stomach ache, it connects those bright colors to that bad stomach ache and will then avoid those bright colored frogs. So it's this frog's way of saying, hey, don't eat me and my friends. So when this bird is flying around looking for a tasty snack after that disappointment with the icky red frog from before, and sees this dark-colored frog, it might think, hey, I just found a safe, tasty snack. However, that bird would be wrong, because that was also a strawberry poison frog, just a different color from a different place. Strawberry poison frogs have a lot of different colors, and this immense color diversity makes them special. Other poison frogs also have color diversity, but strawberry poison frogs are particularly diverse. And this diversity in color poses a prey-predator communication conundrum. So if you were to think about like chip bags, for example, and advertising chip bags, if you were to get a spicy chip from the bag on the right, you'd be confused. Just like the bird from before was confused to get a spicy frog. So why does the frog on the right not advertise its spiciness like the one on the left? Why are they not all the same color? Wouldn't it be smart for both of them to take advantage of that bright coloration to avoid predation? This is the underlying question to my research, and I'm using diet to answer it. Because, like they say, you are what you eat, and this is especially true for poison frogs. The bugs that they eat, like ants and mites, have toxins that when the frog eats them, makes their skin poisonous. And actually, without these very specific bugs, so in a captive environment where they can't find these bugs, like in zoos, poison frogs actually aren't poisonous. But they keep their bright color because these bugs don't give them the pigment, just the toxins. So we have this established relationship between color and toxins, where it's like a defense mechanism from predators, like I mentioned before. and then the toxins in the diet, where the diet gives the frogs toxins, making them poisonous. However, we have this third relationship that we can look at between diet and color. Could different diets mean different colors? Maybe, that's what I'm looking at. I want to see if there's any correlation between the diet and color to answer that earlier question of why not all strawberry poison frogs are the same color. And to do that, I look at pictures like this of these bugs that are inside the stomach of a frog that looks like the one on the right. And I focus on those circled bugs, which are all part of a group called mites. And I focus on mites because, like I mentioned earlier, these are one of the toxic bugs that give the frogs its poison. So by using that known relationship between toxins and diet and toxins and color, I can look at that third relationship between color and diet. And then I measure those mites and I count them so I can establish diet trends and look at them across color trends, like the two frogs up here. So I can look at this red frog and see how the mites in its stomach compare to the mites in the dark frog. For instance, the red frog up here ate a lot less mites than the darker frog. And if this is true across the color gradient, if I find that darker frogs typically are eating more mites than red frogs, I can say, maybe this is a driver of this differentiation. And this answers the earlier question of why they aren't all the same color. So that's all hypothetical results, and this is why I want to come up with my research by having it. And now, why is this important? Why is this color differentiation important? Well, this has a much broader implications across the animal kingdom. There are a lot of other animals that use this communication strategy for predators. There are wasps, there are other poison frogs, and also poison frogs are just cool. They're so small and they can still be so dangerous. They're some of the most iconic frog species, yet we still know so little about how their poison works. So finding this stuff out is just really cool. And yeah, I appreciate you all coming to my talk. In conclusion, strawberry poison frogs and their immense color diversity offers a unique perspective into prey-predator communication. Thank you.
John Pestenariu from the College of Human Medicine.
So going under is usually the most dangerous part of surgery. Misconceptions surrounding surgical sterility and the need for general anesthesia lead to excessive overuse that cause negative health outcomes and generally higher barriers to healthcare. Here at the College of Human Medicine, we are delving into the cognitive risks that are accompanying anesthesia, a matter which we can no longer afford to ignore, and something that's a cause for concern for every patient stepping into the operating room. The cognitive toll of general anesthesia is more than anecdotal. Postoperative delirium and cognitive decline are well-documented, evidence-based realities that we must address in order to provide true holistic care. So why do patients choose to go under? The fear factor plays a significant role in patient decision-making, with many opting for general anesthesia to avoid perceived discomfort or anxiety associated with being awake during surgery. Alongside fear, sterility is a concern that's often raised against in-office procedures. However, evidence-based medicine and years of practice demonstrate that we can achieve a clean cut, free from infection, in an office setting. The cognitive concern is amplified by an aging population. By 2050, we expect to see a 47% increase in Americans aged 65 and older. These individuals are the most susceptible to cognitive injury. Our solution: perform wide-awake surgery using local anesthetic and virtual reality as a distractor. Being part of the MSU environment allows us to pioneer these innovations even as healthcare systems resist due to lower profit margins. Our research aims to illuminate a path away from traditional methods and advocate for awake procedures in the office using virtual reality as a benign distractor rather than relying on general anesthesia. It's safer, cheaper, and easier to access. We're not just challenging the status quo. We're confronting a deep-seated industry mindset that equates surgery with high-cost OR procedures that are the most significant source of revenue for most healthcare systems. So we must ask the question: are healthcare systems prioritizing profit over patients? We absolutely believe so. Our approach seeks to redefine the field of surgery and to increase patient satisfaction. As a community-based medical school, our team at MSU CHM is uniquely poised to drive that change in simplifying surgery, leveraging our decentralized model to provide innovative patient care in office settings across the state of Michigan. Over 2,000 patients have embraced the innovative approach at Michigan State University, led by Dr. James Clarkson. This is a testament to the trust in our research and the effectiveness of the methods that we use. Virtual reality is not only a way to reduce the pain of injection, but it also provides anxiolytic effects, especially beneficial for patients with anxiety disorders, with over 80% of our patients requesting it in 2023, some even saying they had fun. At a basic level, VR competes for the patient's attention, acting as a negative feedback loop to diminish the emotional response to surgery, making the overall experience much less frightening. Furthermore, our office-based surgeries offer a 1 to 2 hour turnaround time and discharge directly to the parking lot. This approach significantly improves access, making patient-focused care accessible to all and making it significantly cheaper. Taking surgery from a day-long ordeal to a short, wide-awake office visit means that there are higher patient satisfaction scores, highlighting the advantages of office-based procedures with virtual reality, including lower cost, increased accessibility, and enhanced patient satisfaction. Our VR-assisted technique is not just safer by reducing cognitive injury, but the patient can talk to their doctor during the surgery, and the surgeon can inform the patient on their procedure and post-op care. Wide-awake surgery with VR is not just a technological gimmick. It is a technique that places the patient at the center of their care and ensures a more personalized patient care experience. What we do in the office embodies what it truly means to give person-centered care, empowering the patient and signaling a new era in surgical procedures spearheaded by the College of Human Medicine. So, at the end of the day, the question is stark. Continue with the status quo and ignore the cognitive risks associated with general anesthesia, or adopt innovative, person-centered approaches like those being developed here at the College of Human Medicine. Thank you.
Thank you very much, John. Let's hear another big round of applause for all 9 speakers who we heard from tonight. Thank you, everybody, so much for attending. We are going to be having our 3rd call for Ignite speakers in the fall. So look for it in August and September in the MSU Museum Communications, and the 3rd Ignite performance is going to be in November next year. Thank you all so much for coming. Be sure to congratulate the speakers when you see them, and have a good night, everybody.